Assalamu alaikum warahmatullahi wabarakatuh. Hello Prep 2, how are you today? Today we are going to talk about atoms of elements classification. But first, let's remember that we have studied elements at Prep 1 and atom and its structure. Okay? Before any attempt to classify elements, there was a mess, which means some confusions about the physical and chemical properties of elements. There were no organization of elements, so it was very difficult to find any information about element and how can they react during chemical reaction. So imagine that you are going to a grocery store with no organization. It will be difficult to find out what you are going to buy. So the organization of elements helped us to find more information about elements and make it more easy. So the classification of elements in tables was very important to facilitate their study and find relationship between elements and their physical and chemical properties. The most important attempts were Mendeleev's periodic table, Moseley's periodic table, and the modern periodic table. First, let's talk about the first attempt, which was of Dmitry Mendeleev, or the father of the table, because he was the first one to classify elements according to their atomic weight. So he put some elements in rows by increasing their atomic weight, and he put some elements in columns by the way they reacted, or according to their similar properties. The only discovered elements at the time were only 67 elements, and he uses 67 cards. On each card, he wrote the name, some physical and chemical properties about each element, like melting point, boiling point, density, and other physical or chemical properties. Okay? And he arranged elements in some vertical columns, which were named after that, groups, and horizontal rows, which were named after that, periods. Okay? And he faced some problems during his arrangement of elements. He left some blank spaces for what he said were undiscovered elements. He predicted that some elements were not discovered at that time, so he left some blank spaces for these elements, and so it turned out that he was right when he left these gaps or these blank spaces. The second problem is that he broke the pattern of increasing the atomic weight to keep the similar reacting elements together. So he put the elements which were similar in their properties, even they are different or not arranged according to their atomic weight, in these groups or these columns. So it was a problem. Mendeleev found that elements were arranged in order to their atomic weight could be placed in horizontal rows and vertical columns, and this tabular arrangement of elements in rows and columns presented to us Mendeleev's periodic table, which was the first attempt to classify elements. The second attempt to classify elements was that of Moseley, who found that elements were characterized by their atomic numbers, the number of protons inside the nucleus of an atom, rather than their atomic weights. Okay? And the last attempt was that of the modern periodic table, in which elements were arranged according to their atomic numbers and the way of fitting sub-energy levels, and we are going to talk about the sub-energy levels in the next slide. But Mendeleev wasn't too far off, as Now elements are put in rows as he put them in rows, which were called periods, okay? And their number in the modern periodic table are 7. The vertical columns or groups, their number are 18 vertical columns or 18 groups. The recent studies led to the identification of more accurate composition of atom. These recent studies led to discovering the mean energy level, as we can observe in the following figure, of a definite number of, and there are some definite number of other levels which were known as energy sub-levels. Okay? This atom has some main energy levels, which are 7 in the heaviest atom, and they are signed with K, L, M, N, O, P, Q. And as I said, they are 7 in the heaviest atom. And these are called the mean energy levels, which have some energy sub-levels. Okay? And we are going to study them in the next stages. Okay? These sub-energy levels way of filling with a principle to classify elements or to arrange elements in the modern periodic table. As we can observe in the following figure, which represents the modern periodic table, it consists of 7 horizontal rows or 7 groups. The first one, second, third, fourth, fifth, sixth, seventh, okay, and 18 columns, okay, or 18 groups. So the modern periodic table consists of 7 periods and 18 groups. Elements of the same group have similar chemical and physical properties. That's why, because they have the same number of valence electrons. Valence electrons means the electrons that are lost or gained during a chemical reaction. So they will form the same kinds of ions. Okay? Ions is the state of atom after losing or gaining some electrons. But the question is how to locate the element location in the modern periodic table. Okay? If we want to locate the position of an element like sodium, okay, we can observe that it is located in the third period and group 1A. But if we don't have this table, how can we locate the element in the modern periodic table? By knowing as, or by identifying only its atomic number. First, we will do or arrange the electrons around the atom in the main energy levels, as we can observe in the following figure. For example, argon, which has 18 protons, or its atomic number is 18, and they are arranged in 3 energy levels, okay, as we have studied in the last stage or in prep 1. Okay, so we can configure these electrons around the nucleus. We will observe that these electrons are arranged in 3 energy levels. The first one, which is K, the second L, the third is M. Okay, so the location of element in the period, the number of period is the number equals the number of energy levels. In this case, argon has 3 energy levels, so it is located in period number 3, and it has 8 electrons at the last energy level. So the number of group equals the number of electrons in the outermost energy levels. So it is located in zero group. Zero group contains the elements which have 8 electrons, okay, in their outermost energy levels, and also helium, which is completely filled with electrons, okay. So zero group, which is the last group in the modern periodic table, okay, this group has elements which are completely filled with electrons in the outermost energy level. Okay, the second example is sodium, which has 11 electrons, and they are arranged in 3 energy levels. The first one has 2 electrons, second 8, and the last one has only 1 electron. So it is located in period number 3 and group 1A. Evaluation: complete the following. Mendeleev had arranged elements according to their atomic weight, while Moseley arranges them according to their atomic number. The modern periodic table consists of space periods, 7 periods, and 18 groups. Write scientific terms. The first attempt to classify elements was that of Mendeleev's periodic table. The horizontal rows in Mendeleev's table periods give reason for. Mendeleev left some gaps in his table because he predicted that some elements were not discovered yet, or they will be discovered in the future. That's all about our lesson today, and I hope to meet you in the next video. Thank you.